We're just trying to stream to 4 different platforms just because we can. Trying to see what the stream quality is like. So we stream to Twitch at 30 FPS. Seem to be working okay. And we're also doing LinkedIn. Same 30 FPS. We're now doing Facebook as well. I don't know if it's working or not, but we will just trying it out. So that seemed to work as well. So yeah, the usual spiel. If you haven't tried biomedical.com yet, please go check out the site. Don't forget to provide your feedback. Keep it short and sweet. Today's Sunday, so we're just doing random stuff. Normally we do, what's it, waveform feature extraction detection. So we'll be adding this next on this site. It will be called the CardioQuest bot, because it's essentially the same tool as we already have published. But this one will be a human playing against a robot. So that will be fun. As it currently looks like. Yeah, looks like that. So we covered this in the last couple of streams. We at some stage will go back to doing EEG. So if you did check the site, now it's a good time to share your comments, anything you like, dislike about it, so I can improve it. Probably won't be doing development on this today. Shall we just publish it? It generally works okay. We're still testing. Yeah, so you have an option to add noise. Actually reduce the level of noise to make it by like 10-fold or so, so it's not too large, because the robot is already stuffing the decision making up. It's not making correct decision even if the noise level is minimal. So that's indicating correctly abnormal, and this should be a normal wave, and yeah, that is correct. So that will be a correct rejection. Yeah, that's abnormal, it's missing a bit. So yeah, with no noise, the current setup is not doing any mistakes whatsoever. Yeah, again, normal gets an abnormality score close to 0.1 in this case. So that's good. Another normal, so if I don't click on it, I'll get 10 points. Now my score will go to 0. Because I wasn't paying attention before, so my score went negative. Normally in these streams I actually go over of what's on the site. Yeah, so you already have the EEG game that you can play, but it doesn't have the robot playing against you. We have other things that we will have. Looking at the short description of it, we might need more work on this, but this is essentially, oh, by the way, yeah, an ad for like one of those health headbands. It's not sponsored by them. So this tool is actually showing you image compression. It can be used for any image, of course. In this case, it's showcasing medical data. You can use different, it's a wavelet transform, so you can use different wavelets, decide how many bits you have in the image, the level of compression. So essentially, the higher the compression, the more levels, the more compressed it will be. And the PSNR, meant to, the peak signal to noise ratio, meant to essentially tell you how easy it will be, you'll be able to reconstruct the compressed image back to the original one. Yes, you can increase the number of levels and increase the number of beats. Yes, we can play around with that. What else we got? The feature extraction. Yeah, so it's using the detection type. You have 3 types at the moment: the fast, high-res, SkFuzzy, Tomasi. There's a description of each one at the bottom. And you can see how well it's working. So in this case, the fast algorithm is finding too many points. The high-res is kind of okay if that's what you're looking for. Probably be aiming at the brain, but then you need to define your region of interest to be the brain. For example, this algorithm is not doing that. You can just see the difference it makes on different images. This is an example of a ischemic stroke. So again, the fast still processing is probably doing too many data points. It's not actually producing anything at all. The high-res found all these bits there, some over here, I don't know why. Yeah, the Shitomasi indicating more points. So yeah, so you have to obviously tune these things up to the dataset that you have. There's a bunch of blocks as well. You have some silly images being generated by a DALL-E 3. Some of them are not too bad, some pretty horrendous. Surprisingly, we get some relevant ads. I don't know about that. It's not sponsored by it. It's just Google ads. I think I covered this one before. We have a standard, not standard. This is from an implant EEG, 16 channels. You can scroll through the data and see what the frequency spectrogram looks like. And we have a similar tool that actually converts the EEG into music. So I don't know if let me know if it sounds like music to you. Right, this one give me an ad to learn how to play piano in only 21 days. Again, not sponsored by that company, whatever that is, school, music school. Anyway, those need some more development, but essentially the auto volume will make the volume very quiet when there is no seizure, like at the end of this data sample. And we know there is a seizure in the middle, so it will become louder. The auto duration will adjust itself to the window size. By the way, yeah, we need to record. So ideally, we'll record the instruction video of how I'm using this tool and pop it on the website at the bottom. So yeah, because no one reads text. Well, at least I don't. I assume others don't read anything as well. So it will be good to have a video showing how to use it. But we might be doing more work on it, so it will change anyhow. Yeah, we'll keep it short today, considering it's Sunday. If anyone wants to join live, can actually do that. Yeah, there's a description of what the project is all about by GPT-4.
Biomedical is actually a term used for a specific project related to biomedical data. It's not a general biomedical engineering concept, but rather the name of an open project that focuses on democratizing biomedical data processing. The term reflects the often chaotic nature of combining biology and electronics, which is a common challenge in the field of biomedical engineering. The Biomedical project provides various tools and dashboards for processing and reviewing biomedical data. It covers a range of topics in signal processing such as statistics, fuzzy logic, neural networks, spectrograms, image classification, and graphic processing. The aim is to help users better understand and predict events and irregularities within biomedical data. It's important to note that this project and its tools are experimental and not certified for clinical or commercial use. The data used in the Biomedical project is de-identified and available in the public domain, and all the tools and information posted on the Biomedical site are released under a Creative Commons Attribution license, allowing for a wide range of uses, including commercial. However, it's currently not possible to upload personal data to the site. Only available public datasets can be used. This project is a good example of how biomedical data can be made more accessible and understandable, which is crucial in the field of biomedical engineering and data science.
Yeah, the bot must have found the About section on the site, and yeah, it does mention that there is no currently an option to upload data. If you do want me to look at any data or for any of your data to be featured on the site, please go upload it onto GitHub or any other public repository. Also looking at another thing, we were thinking adding a couple of extra topics to the mix. So currently we're doing the bot that plays the cardio game. We also have we're also generally looking we'll be trying to review public biomedical datasets, like currently this data on the page is actually using data from IEEG.org. I think anyone can, after a simple registration, can go and get this data. So as I said, we'll be looking at the different biomedical datasets, like the EEG, but the other ones as well. We're also doing eye tracking. Yeah, I don't remember how that went. Probably not great, considering it's not yet available on the site. It's also going to be a Flask application. Sorry. So it is a Flask application, but it's primarily relying on this JavaScript. Don't know why most of the stuff is commented out, but to run it, we actually run a Flask app. Right, this one is running on a different port. Let's see if we can load another camera with it. No, it doesn't seem to work. Yeah, I need to sort out my cameras. I have two connected, but they have the same name. So this page is struggling to actually load the correct camera. Yeah, it just won't work. Just trying it on another browser. Yeah, the problem I'm having is that the two cameras have exactly the same name, so that doesn't help, does it? Yeah, one of them got the one of them got stuck. Anyway, today I was really trying to test the streaming on Facebook. That seemed to work okay. I'll be also editing some of the old videos. All the live streams, trying to make shorter, more cohesive videos out of them. And the other thing is, if anyone is interested, We also found this bunch of feed files, so they're essentially coming from a Garmin. I don't know what's a Garmin Edge device. Must be a very... Oh, I didn't expect that. How does that record the fitness activity? Considering it just being placed on the bike, I guess just does accelerometers and stuff. Yeah, some sort of old device, out of stock. Well, yeah, it's actually good. I checked what kind of device it is, considering it's not a wearable. I mean, it's a wearable, but it's worn by the bicycle, seems to be. The other device, we also have one of those older empaticas, so the E4, not the new generation. Interesting how the main change, well, I mean, it looks quite different aesthetically, but the main change seems to be a screen. Must be a touch screen on the device, which makes it more similar to other consumer grade devices like Garmin and the like. The original one, the one I have access to, does not have a screen. And interestingly enough, there's a bunch of Python libraries that we might be able to use. University of Nebraska Medical Center. Yeah, Biomedical. When was it released? Must be ages ago. Doesn't have any dates. Yeah, Python 3.6. Okay, it must be. No, it's was it 3.11? Must be a while back, but I wonder if it still works or not. So I wonder, I also have it connected via a USB. So I wonder if I can just access it that way. Obviously not ideal because it's a wearable. It's normally streaming data to your phone, like Android phone is fine, which is good. But then I was not able for some reason to actually get it to work with my phone. You know, it requires like an account. I don't know why. I don't know why it just doesn't work out of the box. This is an interesting... Okay, so it's only compatible with Windows and you need an Empatica streaming server. Okay. So this might not work. It's just chat, so we are live streaming, you're co-hosting, so quick responses will be great. Do you know anything about the Empatica E4 watch? It's a wearable recording blood pressure, PPG, so blood oxygenation and the like. We have it currently connected via USB to our Linux Ubuntu machine. Any way we can communicate, talk to it? using Python or JavaScript. I eventually would like to make a Flask application that will allow connecting one of those Biomedical watches and streaming data from it. Quick responses will be great. Yep.
To connect and communicate with the Empatica E4 wristband using Python or JavaScript for your Flask application, here's what I found. Python integration. There are Python scripts available for processing data collected via the Empatica E4 wristband. For example, the GitHub repository, empatica_E4_wristband_analysis, provides Python scripts that can organize multiple participant files collected via the Empatica E4 wristband. These scripts help in monitoring physiological signals in real time, including blood volume pulse, BVP, heart rate, motion activity, electrodermal activity, EDA, and peripheral skin temperature. JavaScript integration. The GitHub repository, Empatica E4 client, includes a Node.js module that can communicate with the Empatica BLE server to fetch sensor stream data from the Empatica E4 device. This can be particularly useful if you are considering a JavaScript-based approach. Empatica E4 streaming server for Windows. Empatica provides a streaming server for Windows, which can connect to multiple E4 devices using Bluetooth LoRa and forward their data streams to clients connected over TCP. This server is essential for real-time data streaming from E4 devices to your application. Python library, Pympatica. The Python library, Pympatica, available on PyPI, can be used to connect and stream data from the E4. Before running the script, ensure the Empatica streaming server is running. This library seems to be primarily compatible with Windows due to the streaming server dependency. Given that you're using a Linux Ubuntu machine, you'll have to consider the compatibility of these tools with your system, especially since the Empatica streaming server is tailored for Windows. For real-time data streaming and processing in your Flask application, these resources should provide a good starting point. Remember to check the licensing and usage terms for each of these tools to ensure compliance with your project's requirements.
Okay, now a quick response. So we have it connected to our Ubuntu system. Can we find a driver for it for Ubuntu and talk to the device directly using Python without any libraries? Yep.
As of the latest information available, Empatica doesn't provide a native Ubuntu driver or direct Python library for communicating with the E4 wristband without using their provided SDKs or streaming server. The E4 wristband is designed to work with Android and iOS platforms using their respective SDKs and with Windows using the E4 streaming server. Unfortunately, there's no mention of direct support for Ubuntu or a method to communicate with the device directly using Python without these libraries. This means you might face compatibility issues trying to interface the E4 with an Ubuntu system without using their specified platforms or tools. For more details, you can check Empatica's developer resources. The E4 link is the new name of the EmberLink library and E4 streaming server is the new name of the Windows BLE server. EmberLink and BLE server products will be discontinued in the next months. The E4 streaming server is a Windows application that can connect to multiple Empatica E4 devices using Bluetooth LoRa and forward their data streams to clients connected over TCP. E4 Link is the new name for the library which you can develop your custom application on Android. Read how to develop your Android application using the E4 Link SDK for Android tutorial and connect to your E4 wristbands from your Android phone. A sample Android Studio project is provided that demonstrate how to scan continuously for E4 wristband devices and connect to one at a time and stream values E4 Link SDK sample for Android. First of all, you need to make sure your phone runs at least Android 4.4 KitKat, API level 19. Android 6.0 or newer is recommended. This version is tested also on latest Android 9 and 10. Note, Android 4.3 doesn't offer a stable enough connection, while previous versions don't support Bluetooth 4.0, BLE, at all, and, therefore, are not compatible with the Empatica API. E4 Link 1.0.0 release is meant to be used with Android Studio 3.5 or later. Once equipped with a supported phone, you need to navigate to Empatica Connect developer area and request to become a developer. You will find your API key and all the download links there. Dependencies. E4 Link has the following dependency. OK HTTP client, version 2.7.5. Installation instructions. Download the SDK from Empatica Connect developer area. Open your project in Android Studio. Open your main build, Gradle, project root, and change the trailing lines to The Empatica E4 Android SDK tutorial provides comprehensive instructions for developers to build Android applications that can communicate with the Empatica E4 device. Key points include ensuring compatibility with Android 4.4 KitKat or newer, using Android Studio 3.5 or later, and obtaining an API key from the Empatica Connect developer area. The SDK installation involves adding dependencies and configuration in Android Studio. Usage includes initializing an Ember device manager, registering the API key, and implementing Ember Data Delegate and Ember Status Delegate for device connection and data streaming. For detailed steps and methods, you can refer to the Empatica E4 Android SDK.
Okay, essentially without using any library with basic Python functions or serial libraries, can I connect and talk to this device via a USB connection? We are happy to just give it a go. Yep.
Communicating with the Empatica E4 device via USB using basic Python functions or serial libraries is not straightforward. The E4 wristband primarily communicates through Bluetooth, and the standard method to access its data involves using specific SDKs provided for Android, iOS, or Windows. These SDKs handle the complex protocols involved in data streaming from the device. If you're looking to experiment with direct USB communication, you could explore Python serial communication libraries like PySerial. However, there's no official documentation or support from Empatica for this approach, and the success of such an attempt is uncertain. You'd be venturing into uncharted territory, potentially requiring reverse engineering of the device's communication protocol. Keep in mind that this might violate the device's terms of use and could also risk damaging the device or voiding its warranty.
Well, right, now that should be fine because we can't communicate. It stopped working with my Android. So I can't talk to the device via like the official app. I still would like to use it. So yes, we would like to go with the PySerial, try talking to it directly. Can you provide some code sample that will do it? And also check the USB connections on my machine to determine which device is the Empatica watch. Yep.
To communicate with the Empatica E4 via USB using Python and a serial library like PySerial, you'll first need to identify the USB connection of the device on your machine. Here's a basic outline of how you can do this. Install PySerial. If you don't have PySerial installed, you can install it using pip Python copy coder pip install PySerial. To communicate with the Empatica E4 device via USB using Python and serial communication, you can use the PySerial library. However, keep in mind that this approach is experimental, and I cannot guarantee it will work with the E4, as it's not a supported method by Empatica. List available ports. You can use PySerial to list available serial ports. This helps identify which one is your Empatica E4. Basic serial communication. Once you've identified the correct USB port, you can attempt to establish a basic serial communication. Connect to the device. Once you identify the correct port, you can attempt to open a serial connection. The baud rate and other parameters would be guesses unless you have the specific communication protocols from Empatica. Data communication. Attempt to read or write data. This is speculative without specific protocol details. Remember, this method is highly experimental. The Empatica E4 uses specific communication protocols that may not be compatible with standard serial communication. Additionally, you should verify the correct baud rate and other serial settings for the E4, as the above example uses default values. Proceed with caution and at your own risk. This is a trial and error process. It's crucial to note that this method is highly experimental and not supported by Empatica. There's no guarantee of success, and it may not comply with the device's terms of service. Additionally, without the proper communication protocol, it's challenging to interpret any data you might receive. Proceed with caution and at your own risk.
Okay, a couple of things. Don't worry about any risk if we break the device. That's okay. Now, how do we find which port the E4 is connected to? And also, can you generate the whole script? I understand this prototype. I understand the risk. Don't worry about it. We just need the code that will try and talk to the device. But first, via the Ubuntu terminal, can we list all the USB devices so we try and figure out which serial code we need to talk to the E4? Yep.
To identify which USB port the Empatica E4 is connected to on your Ubuntu machine, you can use the terminal command lsusb. This command lists all USB devices currently connected to your system. Here's how to use it. Open your terminal. Type lsusb and press enter. Look through the output for a device that could be the Empatica E4. The output will not explicitly name the E4, so you may need to identify it by process of elimination or by looking for a familiar vendor, product ID. Now, for the Python script to attempt communication with the E4. Replace dev tty-usb 0 feet with the port that you identify as the E4. This script attempts to open a serial connection to that port and read any data that the device sends. The baud rate and timeout are set to default values and may need to be adjusted. This script is basic and may not successfully communicate with the E4 due to the device's specific communication protocols. However, it's a starting point for your experimentation. Proceed with understanding that this is an untested and unsupported method.
Read the device. Okay, maybe I need to press something. There's only one button on this thing. It's flashing different colors depending on how long you press on it. Now we can try connecting to it via Bluetooth. And pretend Ubuntu is an Android device. Is that an option?
Pretending that Ubuntu is an Android device to connect to the Empatica E4 via Bluetooth is not a straightforward task. Android and Ubuntu have different underlying architectures and Bluetooth stacks. While it's theoretically possible to emulate some aspects of Android on Ubuntu, this usually involves running an Android emulator, which doesn't typically include Bluetooth hardware access. A more feasible approach might be to explore Bluetooth programming on Ubuntu directly, using libraries like BlueZ, the official Linux Bluetooth protocol stack. However, this still requires a good understanding of the Empatica E4's Bluetooth communication protocols, which are not publicly documented and might be challenging to reverse engineer. For direct interaction with the device's hardware and software, it's generally recommended to stick to the supported platforms and methods provided by the manufacturer. Attempting to communicate with the device in an unsupported way, like treating Ubuntu as Android, is likely to be complex and potentially unsuccessful.
How to list all serial ports currently available using the terminal. Yep.
To list the available serial ports on your Ubuntu system using the terminal, you can use the following command. This command will display a list of all TTY devices that your system recognizes. Look through the output for devices that could be your Empatica E4. The device might not be listed as dev TTY USB 0. It could be under a different TTY name depending on how it's recognized by your system. Remember, if the device is connected via Bluetooth, it might not show up as a traditional USB or TTY device. Based on your terminal output, it looks like your Ubuntu system is recognizing a USB ACM device as TTY ACM 0. This could potentially be the Empatica E4 device. To try communicating with it using Python and PySerial, you should use dev TTY ACM 0 as the port in your script. Here's an adjusted version of the previous Python script using this port. Replace the port with dev TTY ACM 0 and run the script to see if it can establish communication with the device. Keep in mind that this is still an experimental approach. The error you're encountering, permission denied, dev TTY ACM 0, indicates that your Python script doesn't have the necessary permissions to open the serial port. This is a common issue on Linux systems. To resolve this, you need to grant your user account permission to access the serial port. One way to do this is by adding your user to the dialout group, which typically has the required permissions. Here's how you can do it. Open your terminal. Run the command sudo usermod ag dialout $user. Log out and log back in, or reboot your computer for the changes to take effect. After doing this, try running your Python script again. This should resolve the permission issue, allowing the script to access dev TTY ACM 0. Remember, this is still an experimental method and may or may not successfully communicate with the Empatica E4 device.
Yeah, don't worry about the warnings about it's not being successful. That's fine. It's okay. I don't think that's the ID for the device, because when I unplug it, that ACM0, TTY ACM0 still shown by the grep TTY command. The device is connected, the USB has 4 pins, so you should be able to communicate with it. It's not just for charging. What are the different ways of seeing how it comes up when connected to the Ubuntu system? Yep.
If TTY ACM 0 remains listed even after you unplug the device, it's not the Empatica E4. Here are some alternative methods to identify the correct device. Monitor DMESG logs, run --DMES. Run DMESGW in the terminal. Plug in and unplug the device. Look for changes in the output. The new entries should give clues about the device's identifier. Use ls dev before and after connecting. Run ls dev greater than before.txt before connecting the device. Connect the device, then run ls dev greater than after.txt. Compare the two files with diff before.txt after.txt.
USB disconnect device number 43. Okay, we have a MAC address and stuff. Okay, let's clear this for a sec. Oops. Okay, so we unplug it. Run that command.
Based on your latest DMESG output, it looks like the device connected to your system is identified as low-energy dongle by BlueGiga, not the Empatica E4. This dongle is likely used for Bluetooth communication and is recognized as TUH-EEG. The Empatica E4 might not show up as a standard USB serial device, especially if it's primarily designed to communicate via Bluetooth. If it's not registering as a USB device for data transfer, you might not be able to communicate with it via USB serial communication as you would with other devices. Since the device isn't being recognized as you expected, you might need to explore other methods to communicate with it, possibly reverting back to Bluetooth communication or seeking support from Empatica for further guidance.
Yeah, we're getting a MAC address from it.
It looks like the device you're connecting and disconnecting is consistently identified as a low-energy dongle by BlueGiga, which is shown as TUH-EEG. The repeated connection and disconnection of this device suggest it's the same device each time. If you're getting a MAC address from the Empatica E4 and it's meant to communicate over Bluetooth, the best approach might be to explore Bluetooth communication on Ubuntu. Since the device is designed for Bluetooth and the USB connection seems to be identified as a dongle rather than the E4 itself, Bluetooth communication might be the more viable option. For Bluetooth communication on Ubuntu, you could use the BlueZ stack, which is the official Bluetooth protocol stack for Linux. You can use it to pair and communicate with the E4, provided you have the right tools and knowledge about the E4's Bluetooth communication protocols. This method would involve using Bluetooth-specific commands and libraries, rather than trying to communicate over USB.
Okay, can you help us doing this? Don't worry about the warnings. We are happy to break this device if necessary. It's not working with my phone anyway. Python code will be great. and we're currently using Bluetooth. Can we have, not sure if I can have more than one device connected. I have my headphones connected at the moment. Yep.
To attempt Bluetooth communication with the Empatica E4 using Python on Ubuntu, you can use the PyBlues library. This library allows for Bluetooth communication in Python. You can indeed have more than one Bluetooth device connected to your system, like your headphones and the Empatica E4. Here's a basic outline for a Python script to scan for Bluetooth devices and attempt communication. First, install PyBlues. Then, you can use the following script to discover Bluetooth devices. This script will list all Bluetooth devices in range. Once you have the MAC address of your E4, you can attempt to create a socket connection to it. Keep in mind that successful communication with the E4 will depend on the device's specific Bluetooth protocols and services, which may not be publicly documented. This script tries to connect to the E4 using a Bluetooth socket. Adjust the MAC address and port number as needed. As with USB communication, this approach is experimental and might require adjustments based on the E4's specific requirements. The information you provided from the DMESG output does not include a MAC address for the Empatica E4 device. The MAC address is necessary for Bluetooth communication, and it typically looks like a series of 6 groups of 2 hexadecimal digits, separated by colons, e.g., XX, 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 XX. In your output, the device repeatedly showing up is Low Energy Dongle by BlueGiga, identified as TTY-ACM0, which is likely a Bluetooth dongle and not the Empatica E4 itself. To find the E4's MAC address, you might need to use a different approach, such as scanning for Bluetooth devices with your system's Bluetooth manager or using the command line. Once you have the E4's MAC address, you can use the previously provided Python script for Bluetooth communication. Remember, the key to establishing a Bluetooth connection is having the correct MAC address of the device you want to communicate with. If the E4 is not currently working with your phone and you're unable to find its MAC address, it may be challenging to establish a connection via Bluetooth using Python.